I thought I'd give you a kind of an update on my battery project. These are the two proof of concept um, battery packs that I created. This one on the right was done yesterday evening, and the one on the left was done just a few minutes ago. The one on the right, I don't know if you can see, but there are, well, for one thing, these 18650s are 3.7 volt nominal, and the ones I'm planning on using for real will have about 20, about 2,000 milliamp hours of capacity. So this one, I think I might have over-designed a little bit. This is um, 6 gauge twisted copper wire, which I believe has something like a capacity of about 55 amps. And it's very thick and kind of hard to work with. And you can see that's a really ugly joint there. But each one of these cells is connected to the bus bar with a 5 amp fuse, both on the negative side and over here on the positive side. This is a different technique that I think may be a little easier to work with and may be just as safe, I hope. Each one of these strands is a single strand of, I think it's 14 AWG solid copper wire, which I believe has an ampacity of about 15 amps for each one of these strands. So each strand, I don't know if the camera can pick this up, but each strand is connected, maybe it'll be easier to see on this side, with a 5 amp fuse. I don't know if you can see that, but there's a 5 amp fuse going from each cell to the bus bar. So if any one of the cells goes berserk, the 5 amp fuse should blow. And as you can see, on the bus bar, because it gets thicker as it goes along, this is where the connector will connect. We'll crimp some form of connector over here, and I'm planning on getting zip ties to hold these together. I just bent some copper just for the sake of doing this, and I'm going to have to clean that up somehow. I'm not really sure what I'm going to do there. But I read online that the bus bar actually needs to be, ideally, have more capacity the closer it gets towards the connector, I suppose, because it's dealing with more power that's coming from the collective cells. So this one, because the strands are so much smaller, it's easier to deal with than the 6 AWG over here, which absolutely should be able to hold all of the be able to take pretty much whatever is thrown at it. This, I'm seeing people online using this technique. They're saying that 15 amps per strand is enough to be able to handle all this, especially when we are fusing each cell with the 5 amp fuse. So this is proof of concept. This is a 24 by 5, so 20 cells. Each pack, when we actually build it, each pack will actually be 4 by 25. So each battery pack will have 100 cells, and there will be a total of 7 cells. So they're obviously in parallel, and I'm planning on putting 7 in series to try to get up to 25 volts, and I'm hoping that from what I've been told, each cell has about 7 amp hours of storage. If you have 2,000 milliamp cell and multiply that by the 3.7 volt nominal and divide that by 1,000, I've been told that that gives you the amp hour. So that would be about 70 or excuse me, about 700 amp hours of capacity per cell. So per battery pack. So that would mean that when all 7 are constructed and put into series, I'm hoping my math is correct here, that we would have 25 volts and about 0.7 of a kilowatt of storage. Anyway, that's the current update. So let me know what you think. Please, I know you know a lot more about electricity than I do, so please give me your opinion about what you think of both designs.